Let's look at some more of these less obvious substitutions here. What about this one, okay? Run through the whole process again. Is it simply power of x? No. Okay, what's next? Can I think of what I take the derivative of to give me that? Nah. Is it a formula to learn? No. So what's the only other method I know? Use substitution. So we're going to let u equal to 4 minus x. We're going to try, okay? So du over dx is equal to negative 1. So that means du is equal to negative dx. So let's see. I'm going to have this as, let me go ahead and commute these two factors, okay? I'm going to have this as the square root of 4 minus x times x dx, okay? Now I'm going to have the integral of the square root of, what did I let this part be? U times x dx. Well, over here, I can get dx by itself by multiplying by negative 1. So negative du is equal to dx, right? So for this dx, I can replace it with negative du. But let's take care of this x as well while we're here, okay? Look at this part right here. What if I solve for x? One thing I could do is I could go ahead and add x to both sides. So x plus u is equal to 4. And then x is equal to 4 minus u. So instead of x here, I'm going to have 4 minus u. All right, let's bring this negative that's being multiplied all the way to the front of the integral side. And this u that's under the square root, let's call that u to the 1/2. And then 4 minus u we're going to bring down as well as du. So we're going to take this u to the 1/2 and distribute it here before I do any integration. So I still have the integral sign. Then I have 4u to the 1/2 minus u to the 1 plus 1/2, or 3/2 du. Now I have this in a form where I can go ahead and start integrating. All right, so let's bring down the negative sign. And then what is the antiderivative here? Well, let's take the 4, put it out front, and take the antiderivative of u to the 1/2. What would that be? U to the 1/2 plus 1, or u to the 3/2, divided by 3/2, or I could say multiplied by 2/3. Minus this part, if we integrate it, we get u to the what? 5/2. Instead of divided by 5/2, I could say times 2/5 plus c. Well, what is this going to give me? If I distribute my negative through here, I get negative 4 times 2 is negative 8 over 3 u to the 3/2. If I distribute my negative here, I get plus 2/5 u to the 5/2 plus c. And that gives me negative 8/3, but instead of u to the 3/2 plus 2/5 instead of u to the 5/2 plus c, I'm going to end up back substituting. What was u? 4 minus x in each case. 4 minus x. There we go. There's my antiderivative of that. All right, let's look at what's next. What's next? For D as in dog. For D as in dog. For D as in dog. I have something that looks like this. The integral of dx over x times natural log of x. I don't know. I don't like this stuff being up top. So what I do is I factor it out to the side. I just do a rewrite. That's 1 over x times natural log of x dx like that, okay? All right, so I'm going through in my head the different steps, okay? I'm not going to repeat them again. But what do I want to make u be this time? Well, I'm going to try to let u be natural log of x. So if I go ahead and take the derivative of both sides with respect to x, what do I get? 1 over x, right? So du will equal to 1 over x dx. So over here, what do I have? Well, I want to rewrite it to make it look something like this right here, okay? So I need dx here, but I need 1 over x multiplied by it. Can I take this 1x and factor it, or 1 over x right here, factor it out like that? Then what am I left with? I'm left with 1 over natural log of x like that, right? So this is the integral of 1 over, what was the natural log of x? What do we call it? U times, what's 1 over x dx? We call that what? Du. Well, what is the antiderivative of this? Natural log of the absolute value of u plus c, right? Let's back substitute. Natural log of the absolute value, what's u again? Natural log of x plus c. Now my natural log of x will not always be positive, so I can't replace it this time with some parentheses. I have to keep it as the absolute value. All right, some formulas. All right, let's suppose I have this. I think we looked at this in the last section actually. If we have 1 over a squared plus u squared du, okay? It's going to be a formula. If I have 1 over some constant squared plus some variable portion squared, like this that I'm trying to integrate, what I say is that's 1 over the constant part that's being squared times the inverse tangent times the inverse or arc tangent of u over a, so of the variable part that's being squared, over the constant part that's being squared, plus c. All right, then I have this one. I have the integral of 1 over the square root of a squared minus u squared. Now remember, a is a constant that's being squared. U is a variable part that's being squared. Du. Sorry about the telephone. All right, so what does that equal to? Well, we saw that before, didn't we? Didn't we say that's the inverse sign of u over a plus c? And then we have this one that's a new formula for us, okay? What if we have 1 over u square root of u squared minus a squared like this, du. All right, your book says this is 1 over a inverse secant, the absolute value of u over a plus c. Memorize those 3 versions. You can assume in this class, if you go on to take Calc 2 and Calc 3, you'll probably see them there and so forth. All right. Which one do I want to do first, A or B? Let's do A first. Suppose we're going to integrate dx over square root of 9 minus 4x squared like this, okay? Well, I like to pull the dx to the outside, just preference, okay? It's kind of like your toilet paper. Do you like the toilet paper roll going like that or like that? It's just a matter of preference, right? All right, so I'm going to pull this to the outside, okay? Then I have 9 minus 4x squared. All right. This looks a lot like this form right here, okay? Now let's make it look like this as far as some number squared and some variable portion squared, okay? So I'm going to do a rewrite. I'm going to say this is 1 over the square root of, instead of 9, I want something squared. What square gives me 9? 3. Minus, instead of 4x squared, I want something squared. So wouldn't that be 2x like that squared? Dx, right? Now, right here. Notice that this is just the variable part that's being squared, okay? U squared, we're assuming that U is the variable. Right here, I do not have just the variable part squared. If I had just x squared, then it'd be just a variable. But I have this constant multiplied by x, which was 2. So whenever I have that happen, whenever I have something else besides just x squared here, I'm going to use a u substitution. I'm going to say, let's let u equal to whatever's being squared right here, which is 2x. So du over dx is equal to 2. Or I could say du is equal to 2 dx, or 1/2 du is equal to dx. 1/2 du is equal to dx. All right, so let's come back over here. And we're going to say 1 over the square root of 3 squared minus, what did I let 2x be? Let that be u. Minus u squared. And what is dx now? dx is 1/2 du. So times 1/2 du. Let's factor this 1/2 to the front of the integration symbol. So we have 1/2 times the integral of 1 over the square root of 3 squared minus u squared du, right? Now, does this fit this form? What is my a in this case? My a is what? 3, and my u is u, right? So what could I say? I could say this whole thing right here is going to be equal to the inverse sine of u over a plus c, right? So I could say this is going to be 1/2 out front times this stuff, inverse sine of u over a. U over a, but what is my u? My u is u, right? But what is my a? What is my constant that's being squared? 3 plus, don't forget about your arbitrary constant, plus c. Well, let's back substitute. Let's get this in terms of x instead of u, because it started out in terms of x. So we have 1/2 inverse sine of u, which is what? 2x over 3 plus c. There we go. Part B. Then we're finally to the end of this section. Oh yes, we're so happy. B, what if we have the integral of dx over 5 plus x squared, okay? We want to integrate this. First thing I like to do is I like to pull this dx to the outside. 1 over 5 plus x squared dx. All right. Now look at this. It's not simply a power of x. And then I go on to my second thing I try. What do I take the derivative to give me this? I don't know. So go on to the third thing, which is what? Is this a particular formula? Well, yeah, it is. Looks a lot like this formula right here, right? So let me write it better in this form, okay? Because I want a squared, my constant squared. So I want to write 5 as some number squared. How do I write 5 as some number squared? Well, 5, couldn't I write as the square root of 5 squared? Won't that give me 5? Now, does it match this form? It sure does. Now, do I have something else here besides just my variable squared? Like last time I had 2x squared, right? No, I just have my variable squared, so I don't have to do the u substitution this time. I could just apply the formula directly. And what's my formula directly? 1 over the constant that's being squared. So 1 over the constant that's being squared, square root of 5, times the inverse tangent of u over a, so of my variable that's being squared, over my constant that's being squared. My variable that's being squared is x. My constant that's being squared is square root of 5 plus c. Now, if you go look at Wiley or whatever, I think they're going to rationalize this denominator. So they'll write this as square root of 5 over 5. And they use arctangent here. Arctangent of x, actually square root of 5 over x. I'm sorry, square root of 5 times x over 5 plus c. That'll be all right as well, okay? So either one of those versions will work. But for Wiley, for some reason, it won't let you put this. You have to put arctangent.